Welcome to our mathematics class. So in today's class, I'm just going to explain on surds and the manipulation of surds. So for this one, it's a mathematics lecture. That simply means that I'm going to go in detail in terms of explanation. For the revision, I'm sure there is a video on our YouTube channel which you can utilize and revise. It is short and it has less than 20 minutes. So for this class, we'll look at surds and manipulation of surds. So feel free to ask questions, feel free to participate, because this is a class and you guys are supposed to make sure that you understand every content. So like I've already stated, we are going to look at surds and the manipulation of surds. Surds and manipulation of surds. So the first thing that we need to look at is the definition of surds. We need to know what are surds, okay? So surds are just like other numbers, but in this case, when you talk of surds, surds are just numbers left in root form, okay? Surds are numbers that are left in root form. Okay, let me quickly write that. So surds are numbers. Surds are numbers that are left in root form. Okay, that are left in root form. So when you talk of surds are just numbers that are left in the root form, such as you can talk about, let's say, square root a, and then when you talk of a is any real number whereby a should not be less than what? Should not be less than 0. So why is it that these numbers are left in this particular form? So the reason why these numbers are left in the root form is just for us to make sure that we have an exact value. Okay, the reason why these numbers are left in that particular form is just to make sure that they are left in an exact value. Okay, so examples of surds, we can look at examples of surds. Can someone give me an example of surds? Can someone quickly give us an example of surds, a surd number? Anyone to give us an example of a surd? Sorry? Correct. So square root 5 is an example of a surd. So we can just start from square root 2. We can get square root 3. We can get square root 5. We can get square root 7. We can get square root 11, and so on and so forth. So when you look at surds are just numbers which are left in the what? In the root form. So the reason why these numbers are left in the root form, we need to understand that we just want to have the exact value. So remember, according to our title, we are saying surds and manipulation of surds. So from this information, you need to understand that we can easily manipulate surds. We can easily manipulate surds by following the rules below. So by simply following the rules below. So the rules that I'm going to give are the rules that you are supposed to follow for you to manipulate these surds. So from the definition, we are saying surds are numbers that are left in root form. Okay, for example, they are left in square root a, where a is greater than what? 0. Okay, so we need to understand that a should be greater than or equal to 0. Then one thing that we need to look at examples of surds which I've already given. We have square root 2, we have square root 3, square root 5, square root 7, square root 11. So these are just examples of surds. So we can easily manipulate surds by following the rules which I'm going to give. So make sure that you follow all the rules that I'm going to give, because these rules are the ones that will help you how to work out surds. So I'm going to start with the first rule, which is rule number 1. I'm going to start with the first rule, which is rule number 1. So square root AB is the same as square root AB is the same as square root A dot. So this dot is just standing for multiplication. Get me right on that, guys. The dot here is just standing for what? Multiplication. So square root B. So in most cases, because you need to understand that as we go further in mathematics, we're going to be having a bigger expression. So where we put a dot, we are just simply saying multiplied by. Okay, so this guy here, it is just simply talking about multiplication. Okay, so this is multiplication. So you guys should make sure that you know what I mean when I put a dot. Okay, so in other words, what I've written here is the same as square root A times square root B. It's just one and the same, just that instead of putting a multiply by, I've put a dot. So this is the rule that you guys are supposed to take note of first, which is square root A multiplied by B is the same as square root A dot square root B. For example, okay, I'm going to give an example for this one. So let's say you have square root 6. Okay, let's say you have square root 6. So square root 6 can easily be manipulated in such a way that we can have two factors of square root 6, such that you can simply say square root 6 is the same as 3 times what? 2, because we know 6 is the same as 3 times 2. So this is the same as square root 3 dot square root what? Square root 2. So they are one and the same. So this is the first way you can manipulate surds, and this is one of the way that you can do it. So this, I'll make it as my first example on this particular rule. Another example on this particular rule I can give is square root 32. Okay, so when you look at square root 32, this can be written as square root of two numbers, which we can pick is 16 times what? 16 times 2. We know that 16 times 2 is the same as what? 32. So this can just be written as square root 16 dot square root what? 2. What is the square root of 16? Can someone help us? What is the square root of 16? What is the square root of 16? 4. So this is the same as 4 square root 2. Okay, so we have worked out this particular example when it comes to this rule. So one thing that you need to understand is that these rules are very important, especially when it comes to manipulating the surds. So like, look at this one. This was square root 32. If you look at square root 32 is a big number, but we can easily manipulate square root 32 and change it into what? 4 square root 2. So this is the first rule of surds. I hope you guys have followed. I don't know if there is any question. Do we have any questions, ladies and gentlemen? Any question? I can see Florence with a hand. What's your question, Florence? Florence?
Sir, may I have a question? Why do they have to find the square root for 16 when either they're not finding the square root for the square root for 2? Why did we leave it like that, as in the square root for 16, then multiplied by 2, which we didn't even find the square root of 2?
Okay, so if you remember very well, when I defined surds, I stated that surds, the reason why we leave numbers in the root, it's because we want to have the exact value. Okay, so the exact value of 16 is 4. There is nothing like a point, it's not a decimal, but it is exactly 4. But if you look at 2, square root of 2, it is not what? It is not a perfect number. It is a decimal. Okay. The square root of 2 is a decimal. As a result, we can't find the square root of 2. We can't find the square root of 3. We can't find the square root of 5, and so on and so forth. So that's why we leave them just in terms of surds. Is that okay, Florence?
So in short, if we are finding a square root of a number, if it is giving us a decimal answer, meaning we're not supposed to find the square root of it, we just leave it like that.
Yeah, you just leave it the way it is. Like in the case of the first example, if you look at 3, the square root of 3, it is a decimal. The square root of 2, it is a decimal.
Yeah.
That's why we didn't go further. We don't have a calculator.
Right.
Yeah. Lukundo, what's your question?
So here for expanding square root of 32.
Yeah.
In the back here, the next step, can you also put 8 times 4?
Exactly, you can use that, but you are going to arrive at the same answer. I was expecting that question from you guys. Yeah, I was expecting it. So square root 32 is simply equal to the square root of what? 8 times what? Times 4, isn't it? So this one will simply give you square root 4 dot square root what? 8. And then the square root of 4 is simply 2 square root 8. But this 8 again, it can be expanded such that you are going to have 2 and then you say square root of 4 times what? Times 2. And this will give you 2 dot square root 4 dot square root what? 2. And this will give you 2 dot 2 dot square root 2. And then 2 times 2 is simply 4 square root what? 2. So same answer but different approach. But the only problem with the approach which we have just used right now is that it is a long method. It's long. It will take a lot of time for you to finish. But for the first one, it's only 2 steps, you are done. But the second one, it's having about 1, 2, 3, 4, 5, 6 steps. So that means that you are behind time. Is that okay?
Yes, it's okay.
Alright, so let's quickly move on and look at the last rule of surds. Let's quickly move on and look at the last rule of surds. So ladies and gentlemen, these things are very easy if you practice. These things are very easy when you practice. So let's look at the second rule. So the second rule is such that the square root of A over B is the same as the square root of A over the square root of what? B. The square root of A over B is the same as the square root of A over the square root of B. So this is just a rule which you guys are supposed to take note of. So let me quickly give an example of this particular rule and how applicable this rule can be. So let's say you have square root, let's say you have square root 100 over 9. So you know 9 into 100, it's something giving us a decimal, but this can be worked on whereby you can say the square root of 100 over the square root of 9. Using this rule, you can manipulate that one. So after you manipulate, you know the square root of 100 is just what is 10, and then the square root of 9 is simply what, 3. So this is how easily you can work out using that rule. Do we have any questions before I go on my next part? Okay, so with that, since you guys, no one has a question, so we can easily work on we can easily go on the next part. Okay, so for this one, I'll just write more examples. For this one, I'll write more examples. Okay, so the question is simplify. Okay, for some question they can say evaluate the following, or some question will say simplify the following, okay. So please make sure that you follow up, and make sure that after the class, feel free to visit the YouTube channel where I'm going to send this class. Make sure that you watch as much as you can, and this will help you to revise. So the first one is square root 28. Okay, the first one is square root 28, and the second one I'll put will be the first one I've put is square root 28, and then the second one, which we can simply put, is, let's say we have square root 2 square root 7, 2 square root 7, and then this should be multiplied by, there are some brackets here, multiplied by, then you have 3 square root 7, 3 square root 7. So this is an example. Okay, so let's quickly move on and find the solution for this one. So the first one is A, which is square root 28. So you need to understand that square root 28 is the same as 4 times what? Times 7. So this is the same as square root 4 dot square root what? 7. And the answer for this one, it will simply be 2 square root 7. So 2 square root 7 is the answer for this particular example. Ladies and gentlemen, do you have any question? Do you have any single question? Okay, since we don't have a question, we can move on to, let's say you have 2 square root 7 and then multiply by 3 square root 7. Okay, so for this one, you can easily work on it. By simply saying you're going to multiply 2 square root 7, and then you say dot 3, and then dot square root 7. We are multiplying everything by everything. So you know 2 times 3 is simply 6, then dot square root 7 dot square root 7. Remember, the dots are just standing for multiplication. So one of the rule that you guys are supposed to take note of is that square root a dot square root a, the answer is what? A, meaning square root 7 times square root 7, the answer is simply what? 7. So in this case, this will be 6 times 7. 6 times 7. What is 6 times 7? Can someone try? What is 6 times 7? What is 6 times 7? 42. Correct. So the answer
42.
correct. So the answer for this question,
42.
yeah, you are right. So the answer for this question is simply 42. So the answer for this question was just simply 42. So this is how easily you can work out surds. Any more question before I give more examples? Okay, I have Taonga with a question. Taonga, what's your question?
So if the roots like this one, root of 7
Yes.
multiply by root of
Yes.
7, just
You just what? I didn't get your last part. Taonga?
just write 6 times 7.
Yes. Since it's root of 7 times root of 7, the answer is 7. Okay? Because root of a dot root of a.
After 6 multiplied by root of 7 and root of 7, then you wrote 6 times 7.
Yes. The reason why I wrote root of 6 times 7 is because root of 7 times root of 7, the answer is 7. Because the square root a dot square root a, the answer is a. So if a is 7, like in this case, that means that root of 7 times root of 7, the answer is what? 7. Then 6 times 7 is 42. Is that okay, Taonga?
Yes.
Okay. Florence, what's your question?
So what could have happened if we had a root of 7, then dot root of, let me say, 5.
So in such a case, you have root of 7 and then you have a 6 and then you have a root of 7, isn't it? A root of 5, right? So for that case, you are going to say 6 and then you say 7 times 5, and this will be 6 root of what? Root of 35, like that. The reason is that we are simplifying. So if you leave it like that, then you have expanded. So in such a case, you have to move the way I have moved. Is that okay, Florence? Florence, is it okay?
No, I didn't hear the explanation. It was cutting.
I'm saying if you have 6 times root of 7 times root of 5, you're going to apply the first rule we did. And in such a case, you are now going in the opposite direction. So this 6 times square root 7 dot square root 5 can be written as 6 square root 7 dot 5. So 7 times 5 is 35 and then 6 will remain. Is that okay now?
Oh yeah, I've understood. Thank you.
You're welcome. Okay, so let's move on and look at the third example. Let's move on and look at the third example, which is my C. So for this one, I have open bracket square root 5, and then you have plus square root 2, and then you have squared. So that's the question that we have, and we have been asked to simplify or to evaluate. So this is how easily you can work out this particular question. So you're going to write square root 5 and then plus square root 2 and then brackets 2. So this is the same as open bracket square root 5 and then plus square root 2 close bracket open bracket square root 5 plus square root 2 close bracket. After that, you can simply multiply square root 5 by that which is 5 plus square root 2 close bracket. Then you say plus, you get this one which is square root 2 open bracket square root 5 plus square root 2. After you do that, you can simply work out square root 5 times square root 5 times square root 5, it's simply 5. Then square root 5 times square root 2, it's the same as it's the same as square root 5 dot square root 2, and then you say plus square root 2 dot square root 5 is the same as square root 5 times square root 2. Then you can say square root 2 times square root 2 is just 2. After you do that, you can correct the like terms. So this will be 5 plus 2, and then you know this one and that one can be made to be 10, isn't it? Because inside it will be square root 5 times 2, which is just square root 10 plus square root 10. After you do that, 5 times 2, it is simply 7 plus square root 2 plus square root 10 plus square root 10 is simply 2 square root 10. So this is your final answer. Is there any questions from you guys? Is there any questions from you guys? Any questions? Yes, Florence, what's your question? What's your question, Florence?
Me, I'm a bit confused. I'm a bit confused.
Where?
Here, I try to explain again how it came about with all this as in everything.
All right. So
open brackets.
I will explain everything.
Why did you use the square root 5?
I will explain everything. Okay, so just wait, I erase everything and then I restart to make you understand. Okay, so I'll start. This expression square root 5 plus square root 2 to the power 2 is the same as square root 5 plus square root 2 open bracket, and then you say square root 5 plus square root 2 like that, because this is multiplying by itself twice. Then you are multiplying square root 5 by everything. So you're going to say square root 5 open bracket square root 5 plus square root 2 close bracket. Then you get this one which is plus square root 2 open bracket square root 5 plus square root 2 close bracket. Then you say Square root 5 times square root 5, it's simply 5. So you write 5. Then you say square root 5 times square root 2, it's just simply square root 5 times, which is a dot, square root 2. Then you go again. Square root 2 times square root 5. So you say plus square root 2 dot square root 5. I can either write square root 2 times square root 5 or square root 5 times square root 2, because you know that 2 times 1 is 1, it's 2, sorry. 2 times 1 is 2, and 1 times 2 is still what? It's still 2. Why? Because multiplication is the commutative and the associative. So you can either swap them or you write them the way they are. In the previous solving, I had to put square root 5 dot square root 2 because I know that multiplication is commutative and associative. So from there now you can move on and say plus square root 2 dot square root 2, it's simply 2. Is there any questions from you guys before I move on? Florence, is it clear?
So there on the sign that is separating those two equations, let me say the square for the square root 2, open bracket square root 5 plus square root 2. I didn't understand that part.
This one.
Did we have to apply to multiply square root 2 multiplied by square root 5 for us to get that square root 2 point?
Yes, we are multiplying. We multiply square root 2 by square root 5. That's why there is a dot. That's why the brackets in grade 10, you learn something like 2 open brackets. Let's say you have a plus b. That was under algebraic expression, and this was under expansion. You learned that. So what you used to do is 2 times a, it is 2a. 2 times b, it is 2b. This is what you used to learn. So the same principle which we used here when we were in our secondary school, actually grade 8, even in grade 10 you learned. That's where now we have said square root 2 times square root 5, it is square root 2 dot square root 5. This, there is no sign here. When there is no sign here, it simply means that you are multiplying. So that's why we are saying square root 2 dot square root 5, we write it like that. Then square root 2 times the square root 2, it is the square root, it's what? It's 2. That's why we have written that. So this part here, the one I'm writing in white, it is coming from this other part, which is this one here. So this one is giving birth to that one. Then this one has been brought because of the other one. Is that okay? Florence, are you clear?
Understood, sir.
Alright, good. So then you say 5 plus 2 is simply 7, and then this one inside, it is 5 times 2, it is 10. Even that one will be 2 times 5, it is 10. So in short, you are having plus square root 10 plus square root 10. So when you work out that, it's going to give you 7 plus 2 square root 10. In case you are wondering why has it become 2 square root 10, this principle again we have borrowed from what? From algebra, where we used to say x plus x is simply what? 2x. So this x is just the one which has been replaced by square root 10. Is that okay, ladies and gentlemen, before we move on? I don't want anyone to remain behind because after this there is an assignment. Any question? Okay, no question. Okay, so we can move on and do the last example, which is D. We can move on and do the last example. So this is 2 square root 5. This is 2 square root 5 minus 3 square root 2, open brackets. Then we have open brackets 2 square root 5, and then you have plus c square root 2. Sorry, not square root 2. There is a 3 in front of
sorry,
2.
sir.
Yes.
I think we have a new member, Miriam. She has raised her hand twice and you've not asked her why she's raising her hand.
Oh, Medium. Sorry, I didn't pay attention. My mind was on the board. Miriam, what's your question?
Thank you so much, Lindsay. So I have a question on the previous example.
All right, all right.
I didn't realize how we got is it 2? Yeah, where we got 7 plus 2 square root of 10.
Okay, all right, okay, I get you. So, let me erase that part. I'll repeat once again. The reason why I'm repeating, I explain, you ask me a question, I repeat. It's because this is the part which doesn't miss in the exam. That's why I am repeating. I want to emphasize much on this because it doesn't miss in the exam, and it also doesn't miss in the test. So look, Miriam, you have 5 plus 2 because they are like terms. Then you are going to say plus, okay? So you have 5 and 2 are like terms. 5 and 2 are like terms. Then the next thing you're going to have is 5 and 2 that, according to the first rule, this is the same as 5e times 2, okay? Then you're going to say plus, according to the first rule, this is the same as 2 times 5, like that. Then from there you can simply add the like terms, which is 5 and 2, which is 7. Okay, that's where 7 has come from. Then plus, you are going to get you're going to multiply 5 times 2, it's 10. So you're going to have square root 10 plus square root 10. Okay, so according to the knowledge you have in mathematics on algebra, what is the answer when you say x plus x? Medium, what is x plus x? Medium, what is x plus x? Medium, what is x plus x?
It's 2x.
Correct. So it's 2x. Correct. So it's 2x. That means that what is square root 10 plus square root 10? If x plus x is 2x, what about square root 10 plus square root 10?